Okay, so a linear transformation is a mapping. We're going to have two vector spaces, W and V, and we're going to let T be some mapping from V to W. So this is what we call the domain. This is what we're going to call the codomain. If V is an element of V and W is an element of W, then we say that T of V is W, then V is the pre-image of W and W is the image of V. And if I collect up all of the W's that come from V's, right, so the set of all W's such that TV gives me W for some V in V, then we say that this set is the range of T. Okay, so this is just talking about a mapping. We haven't gotten into what a linear transformation is yet. Okay, so this is our mapping. If I get rid of some of this stuff here, okay, and the following is true, that T of V1 plus V2 is equal to T of V1 plus T of V2, and T of some constant times V1 is equal to the constant times T of V1, then what I have here, then T is a linear transformation. If in fact T is a linear transformation and is a mapping from V to V, then we call it a linear operator. Okay, so the next little piece in this is how do matrices play in. Okay, so we're going to let A be some M by N matrix. Okay, and we're going to have V be a vector in our N, right? So what's going to happen here is that we're going to say that T is going to be, so T is going to be a mapping from our N to our M, right? And T is going to be defined as multiplying the matrix times the vector V, right? So remember that if I multiply something that is M by N times N by 1, I'm going to get something in M by 1. Okay, so basically you can represent a linear transformation going from our N to our M as a matrix times a vector. So in this case, we're going to let A be, let's do an example here, let A be 0, 1, negative 1, 2, 3, 0, 4, 2, 1. So this is my matrix, and it's going to eat some vector. So this vector that we're going to eat is going to be 1, 2, 3, right? And if T of V is equal to A times V, then T of V here is the matrix 0, 1, negative 1, 2, 3, 0, 4, 2, 1 times the matrix 1, 2, 3, and you can work out that multiplication, and you're going to find that this gives me negative 1, 8, 11. So matrix eats vector and returns vector. Now that's like only going to work if I'm in Rn to Rm, and in this case I happen to be Rn to Rn. So this is actually an example of a linear operator, but there you go. So this is like the basics of linear transformations.